Problem number 4 states, two speakers A and B are driven in phase with a slowly increasing pitch. Janet is standing 3 meters from speaker A and 4 meters from speaker B, while Brad is standing 6 meters from speaker A and 4 meters from speaker B. Janet and Brad notice that sound level varies due to constructive and destructive interference as the pitch is increased. So they want us to figure out at what frequencies will Janet notice a maximum in sound intensity, and then at what frequencies will Brad notice a maximum in sound intensity. Okay, so I drew a little figure here. That might not be the best representation, but we have speaker A and B, Janet 3 meters from A, 4 meters from B, Brad 6 meters from A, 4 meters from B. And then, so since they are experiencing changes in interference, we know that's because of overlapping sound waves. So for them to notice a maximum in the sound intensity, that means that the sound waves have to be in constructive interference, or maximum constructive interference. So I just kind of drew out here, constructive is when the waves are in phase there, or in a line, and then the destructive interference would be when they're out of line there. So that would be the minimum sound intensity, but since we're doing the maximum sound intensity, we want to look for the constructive interference. We know the velocity of sound is 343 meters per second, which we will need to find the frequency later on. So I just noted that there. And then so the conditions for max constructive interference are that the phase change for the waves has to be equal to 2 pi times the phase or the path length difference divided by the wavelength plus the change in the phase difference of the sources. That's a lot. So yeah, which is also equal to just m times 2 pi. So m is our nodes, so m is equal to, should be a 0 there, but 0, 1, 2, 3, and so on. And then since we are in phase, we know, yeah, our speakers are in phase, so our phase difference for the speakers is going to be equal to 0. So since that's the case, we can simply say that for the conditions for maximum constructive interference are just going to be that the change in R is equal to m times the wavelength. So like I said, m equals 1, 2, 0, 1, 2, 3, etc. And then that change in R is going to be just our path length difference between the sources. Okay, so to calculate R, for Janet, first of all, she's 4 meters from the speaker B and then 3 meters from speaker A, so the difference in the path difference for those speakers is 1 meter. So then we can take that 1 meter, we can set it equal to, for m equals 1 times the wavelength, and then we can find the wavelength equal to 1 meter, which we can then use our velocity and then find the frequency. So just do the velocity of sound divided by that 1 meter wavelength, and then that first frequency that she'll hear the maximum sound intensity is going to be at 343 hertz. And then we can do the same thing for the second mode. So we just have the same 1 meter equal to 2 times the wavelength, which do the same calculation, and that second maximum sound intensity she'll hear is at 686 hertz, and so on. So we can just use a simple equation here. We can say that the wavelength is always going to be equal to her 1 meter, the change in R, divided by m, when m is equal to 0, 1, 2, etc. And then the frequency is always going to be that velocity divided by 1 over m. So we can say that the frequency that Janet will notice, the maximum in sound intensity, is going to be the velocity times m, when m is equal to 0, 1, 2, 3. And then we can do the same for Brad. So for Brad, his was a path difference of 2 meters. So using the same calculations, his first maximum sound intensity frequency will be 686 hertz, and then his second will be 343 hertz, and so on. So for him, we can say that his frequency is the frequency that he will always notice the maximum in sound intensity is going to be m times v, velocity of sound, divided by 2 when m equals 0, 1, 2, 3. And yeah, this all ties into what we're learning in chapter 17 about interference in 2 and 3 dimensions. And sorry for the shaking.